So today we're going to be putting together everything that we've talked about for the last 3 days and just trying to graph sine and cosine functions with everything that we've learned. So let's first just look at kind of the generic form of both of those functions. So if we have y equals a times the sine of b times x minus h plus k, or the same thing for cosine, we've learned over the past couple of days what all of these transformations what effect they have on the graph. So for example, we know translating up and down or left and right, what we're doing is moving the midline and our starting point. So when we look at the equation, we want to know that k, this number added out here, is what's going to be moving our midline. Our midline should be at 0, but if we're adding something other than 0, that can move the midline up and down. We know that this is a dilation, our A, and so that's changing our amplitude from 1. The amplitude is normally 1, but if we stretch it or squish it, we can change the amplitude to something else. We also know that sine and cosine actually tell us where on the wave we're starting. These two graphs look identical. The only thing that changes is where on the wave do we actually start the graph. So for sine, we said that we start on the midline, and for cosine, we said that we start at the maximum, at the top of the wave. And then we also know that normally we would like to start at the y-axis at 0, but sometimes we do shift it, that phase shift, by starting somewhere different on the circle. And so that's when we use the h to help us shift off of the y-axis, if that's where we want to start our graph. So we can shift it side to side, and that gives us our phase shift. So when you have all of that together in the equation, this is where we get all the information that we need to graph a perfectly fine sine or cosine. So let's practice a few examples. So let's take a look at this equation. So I have y equals 2 cosine 3x plus 1. So important things that I pick up where they are, I notice that my midline has moved from 0, 0. My midline is up at 1. So this is where I'm going to kind of be bouncing around. So again, it's not part of the graph, but I use it as my visual guide, and so it kind of keeps me on track to graph everything in the right place. So I always draw a nice little guideline for me. It is not part of the graph, though. Do not do a straight solid line. It's just a guideline. So if you're going to do it, it should be a dashed line in highlighter or lighter than the rest of the graph. You don't want it to actually appear to be part of the graph itself. The wave is the graph itself. But it is my guideline, so I like to throw it on there. It helps me see where everything is starting. I also noticed that I did have an angular speed listed here. This was our angular speed, so my period is not going to be the normal 360. I'm going faster than that, it looks like. So let's figure out exactly how long it takes to get one cycle done. So if I'm going 3 degrees per second, because notice my graph is in degrees. If I'm going 3 degrees per second, that's going to be 360 divided by 3. So it looks like 120 is how long it takes for me to get one full complete cycle in 120 seconds. So I can do this in 120. So now back to looking at other information. So I know that, where's 120? So starting at 0, because I didn't shift left or right any, and going to 120. So this gives me one full cycle. So I should get a full wave here. Now notice I can fit a lot more of those on here. So after I do one, I am going to go in and want to continue. General rule of thumb is fill the graph that you have with the wave. But one cycle of the wave is going to be 120 seconds. I also notice that my amplitude is 2. So instead of going 1 above the midline and 1 below the midline, I'm going to go 2 above and 2 below. So I also know that cosine starts at the top of the wave, so I'm not going to start on the midline. I need to go 2 above the midline, and I'm going to start up here. I also know that I end at the top, so I'm going to go over to 120, and there's my ending point. So all I want to do is just look at my graph and break it up into 4 pieces. Thankfully, 1, 2, 3, 4, these dark lines have already done that for me. So I know starting at the top of the wave, I should be down to the midline after 1/4. Then I should be down to the minimum. Then I'm come back up to the middle, and I'm up at the top. Cosine is very hard to resist the temptation to make this a V. We need to realize that this is not shaped like a V. This is a down curve, and then it's coming down to the minimum and curving up, and then it's going up to the top. And in fact, now I want to continue that. So each one of these, I'm going down to the midline, down to the minimum, back up to the midline, back up to the top. And so you just want to make sure that it's looking like a wave and not sharp corners. And so now we have 2 full cycles, and it looks like I have plenty of room, so I could keep going down to the midline, down to the minimum, back up to the midline, back up to the top, and we just continue on that little wave cycle. And so this would be 2 times the cosine of 3x plus 1. Let's look at another example. Now let's look at y equals negative 1/2 sine 1/2 x minus pi over 4. So first thing I notice is the midline has not been moved. There was nothing added out here, so my midline is still at 0. So I know it's going to be bouncing around the middle here somewhere. So that's my midline. Next thing that I notice is that it is actually negative. So I want to watch out for that. My graph should go down first, then up, because it's been flipped upside down. I also notice that it's sine, so that means that I'm going to start on the midline. So I know I'm starting on the midline. And I also notice about my start that it has shifted over to pi over 4. It was minus, so that's going to the right. So instead of starting here at 0, I actually need to do pi over 4. So notice the pi over 4 kind of indicates that we're dealing with radians. Pi shows up, that tells us that we're dealing with radians. And my graph is also broken down in radians. But if this is pi over 2, halfway is going to be pi over 4. So that's going to be right here. So here's going to be where I start my graph. Now I need to know how long is the period so that I can actually, break it down and do my graph. So when I look here, I have an angular speed. So my angular speed is 1/2 a radian per second. So if I'm going 1/2 of a radian per second, and there's 2 pi radians to get all the way around the circle, when I do 2 pi divided by 1/2, I actually get 4 pi. So my period is going to be 4 pi. So remember, period is always kind of the one thing we have to do a little bit of computation for, because the graph gives, or the equation gives us the angular speed. It doesn't give us the period, but the angular speed is what we use to find the period. So I need a period of 4 pi. So when I look here, a pi was 2 of these big blocks. So I need to go 4 pi's. So I need to go 8 of these big blocks. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Right here is the end of my period. So that's where it's going to start the sine wave for one cycle and end the sine wave for one cycle. And as always, we know that we have to break that period up into 4 equal pieces. So we said it was 8 for 8 of these big thick lines for the whole thing. So I'm going to divide that by 4, and that's 2. So here would be the first quarter, and then here would be the second quarter, and then this would be the third quarter, and we're all the way to the end. So if you recall, this number here is going to be our amplitude. So that's how far below and how far above we're going to go. So starting at this point, that means I'm going to come down to 1/2. Remember, we're going down because it was negative. So sine normally would go up, but it's negative, so I'm going down. So I'm going down to 1/2, back up to the middle, and then I've got to go up to 1/2 at this one, and then back down to the middle. So my curve, the wave, is not very tall. There we go. And we know that it continues, so I can stick the arrow over here and stick the arrow down here, and it's continuing. If you want to continue it on over to the x-axis, and that gives us our sine. So we find all of the things that we need from the equation, and we can translate that over to the graph.